Hi, my name is Brian Ensign, and this is my final project for designing a wireless network for ITT-370 at Grand Canyon University, March 27th, 2024. The project scope for my business is to design and implement a new wireless network for Alamo Home Builder in San Antonio. The current network is several years old and can't meet the growing connectivity, collaboration, and security needs for the expanding employee base. The existing network doesn't have the technology scalability for adequate security, and the new network will provide secure, reliable Wi-Fi access across all office areas to support their daily needs. Now, the objectives of the network is to support a high number of concurrent users and devices without degradation in performance, to streamline the connectivity of employee devices like laptops, smartphones, and IoT equipment, and enable secure collaboration between teams through file sharing, such as video calls, conferencing, engineering specification reviews, and more. This will also help them future-proof the network to support evolving technologies and future rollouts. Our intended users is about 165 employees requiring wireless access for their business applications, 15 temporary contractors, and about 6 conference rooms for video calls and screen sharing, and some guest access for customers and maintenance contracts. Now, our design assumptions are the wireless network is going to existing ones support some Wi-Fi standards. It's going to be a multi-story building from what we've seen online with various construction materials. A site survey we're going to perform will determine adequate density based on the square footage and building materials, and a phased deployment to avoid any service interruptions. Some budget limitations may require certain areas to use existing equipment initially until the business expands or upgrades. So during our feasibility study, authentication of user devices via 802.11 and Active Directory integration will only allow branded registered equipment onto the corporate Wi-Fi. And deployment of WPA2 encryption to protect the confidentiality of wireless transmission throughout the office, and segmentation of user traffic from wired infrastructure, and firewall rules to isolate any potential threats. That'll allow them to monitor the network through management tools and perform regular security audits and user training. Now, the integration and updates will conduct a wireless site survey to identify any gaps in coverage, and will implement wireless network management tools and control solution to unify any oversight over the hybrid infrastructure. I'm going to deploy state-of-the-art wireless access points and install dual radio access points with MIMOs. Now, versatile information process will allow file sharing and collaboration, VoIP video conferencing for things like Teams, WebEx, and Zoom, and enterprise resource planning for things like SAP and Oracle. This will allow the teams to collaborate via virtual private network access, will allow employees to securely access the network. They'll be able to use cloud-based file sharing like OneDrive, Dropbox, and Google Drive, and audio and video conferencing to host virtual meetings through Teams, Slack, or Zoom. We've got remote desktop applications, intranet web portal for communication of company initiatives, and user support ticketing so remote teams can help. This will allow them to scale and upgrade wireless infrastructure, which uses their standard 802.11 standard to support new features. Change management, which will allow new device onboarding, and switching and routing to scale vertically. Now, the intended users, the wireless network should be able to support mobility and secured collaboration, again with 160 users, about 15 temporary contractors, 6 conference rooms that are going to have microphones, cameras, VoIP phone systems and speakers, and guests. Now, our design assumptions are the building floor plan and construction materials are typical office material, and there's no significant source of interference, no huge mega steel beams in the middle of the building, but our site survey will validate this. The number of users and devices connecting the network daily will increase no more than 20% annually, and allow some growth over the next 5 years. Network switches will have adequate available ports and throughput on connected to the new wireless network. Now, if any are broke, we'll take care of those, but we're assuming most of them are functional. And existing data cabling and pathways between floors, walls, ceilings, we've got access and egress to get in and out of there and get that installed. Now, the enterprise technology team should have the skills available and training to be able to implement and be able to maintain this going forward with some support from us. And the budget necessary, the stakeholder approval timelines will allow us to get this done in the next 4 months or so. We're predicting they're having no major organizational changes that are foreseen in the near future, and they'll mandate that employees keep their devices up to date. Now, we've got a breakdown and proposed basic equipment needs for a proposed budget. It has a controller, some access points, network switching, cabling, a site survey, project management, small contingency plan, and a small budget We were initially anticipating about $70,000 for a turnkey package of high-quality networking, switching, and control equipment that allow Alamo Home Builder to be more successful. Now, the network analysis needs to be successful with these applications to be supported over wireless network, as project management software is going to be used. They're going to use things like Oracle, iDocs, and Ensemble of Bluebeam to do engineering reviews, make Gantt charts for scheduling. The data will be used by 165 employees with 15 contractors, but they're going to need some VPN for people working remote traveling, as well as some extra up in the front for the lobby to support guests coming in and transactions up front. With about 50 access points, we should be able to blanket the building really well. The daily current users and the heaviest usage will be about between 8 and 5 when employees are on site, and the usage bandwidth for intensive apps and large file transfers will be taken care of by this. We're expecting about a 10 to 25% annual growth rate, the network for the next 5 years, and be able to support about 250 average daily users simultaneously. We're estimating about a 25 terabyte per month usage based on all of that. After meeting with them, we've outlined a report that will explain how our home design of the newly proposed wireless network will avoid network congestion, and we've got some great security solutions for them. The sales kiosks to process custom home design and bids are critical up front, and spectrum analysis during our surveys will validate the sufficiency of any non-overlapping channels that exist in location. For business requirements uptime, a secondary wireless controller and backup spectrum access system controller will be deployed. The wireless system infrastructure is designed with fully redundant hardware and power supplies and to be able to handle all of that. And a phased deployment approach will take place so we can validate operations and minimize downtime. Now, the QoS requirements will need to prioritize the voice traffic, dedicated bandwidth for voice calls, and keep VoIP nice and clean, since that's needed the most is communicating with your clients and getting transactions done. And the sensitivity of the IP phone systems is sensitive to latency and jitter. Strict QoS measurements are needed to get these devices working well as a result. Now, running the phone systems is a priority, and the traffic through a router to avoid network congestion is the best way to avoid any conflicts. The reliability and security requirements are key to us, and they have a lot of potential for security threats. We provide a lot of defense for that, for man-in-the-middle attacks, defending network packet filtering, intrusion detection systems. Employee device spoofing will be blocked by enforcing strict authentication and rotating encryption keys, with digital certificates monitored to stop man-in-the-middle attacks. Wireless intrusion detection systems with rigorous radio frequency scanning from our support team will detect any unauthorized rogue access points. Now, they're going to process data safely once we get out of there by using encryption methods supported by commercial product vendors. The Wi-Fi networks will use WPA3 256-bit encryption as available, and WPA2 with radius authentication servers when they can't. All of the traveling and sales personnel will use a VPN with multi-factor authentication and MAC filtering, along with full disk encryption will be mandatory for any employees using laptops. Now, we've got a detailed design document that involves using a single Cisco Catalyst 9800 controller, 50 Cisco Catalyst 9100 access points, a 48-point Cisco Catalyst 9300 switch, 1,000 feet of cable, along with your hardware, your crimps, all of your connectivity needs for the networking, the labor, equipment staging, rack assembly, access points, configuration testing, documentation and training, project management, and all your as-builts will all be taken care of. Now, the cost breakdown, which we quoted prior, about $70,000, we gave you guys a little bit of a discount on. That'll include everything I just mentioned, a small contingency plan. We did give you a small reduction in the project management costs and the site survey. Since we did our homework, we looked pretty good. We feel very confident that from what we've seen on the outside, you guys are going to have any major issues. So we'll hope to be able to work with you guys coming down a little bit at $67,870. I think it's a great deal. We want your business, and we're looking for a long-term partnership here with you. If you have any questions, please give us a call. We're like family to you guys. So all of the things on the last page are the references. I've really enjoyed doing this class. I've learned a lot. I do some of this at work, and I think it's kind of fun being able to do this for school. There's definitely some wireless things that I thought I knew that I didn't, and I've really learned a lot, and I really appreciate the communication with you, both being open for a phone call, which I don't usually do, and just some of the messages on the side. I've had nothing but fun in this class, so I really appreciate it. So the last page, there wasn't a instruction on how to deliver this. I didn't know if it was supposed to be a file attachment, via export, if you wanted a picture, what that looked like. So I just took a screenshot of the networking. I've got the switch, the wireless access point, the server, the router, some wireless PC devices to simulate in office, another access point. You got your controller. I did DHCP at first, and then I manually assigned some IPs. You can see everything's lit up and connected. And then I did ping them to ensure that they could communicate via 192.168, 1-3, 1-5, 1-6. There's an example of 1-6 with a ping. And I put my name on there so you knew that was me. This wasn't downloaded off the internet or anything like that. I've used Packet Tracer before. It's actually a really fun tool. I originally had this big, huge network set up with printers and phones and stuff, and I thought, man, that's overkill. He doesn't want to see all that. So anyway, thank you so much for listening. I really appreciate it. This has been an amazing class. Have a great weekend.